Hello all, so today we will see thermodynamics. Okay, in thermodynamics first we have to understand the basic concepts of thermodynamics. Okay, so first I will tell definition about thermodynamics. Thermodynamics means it's a study of interaction between heat and temperature. Suppose if I take any body, okay, if I take this is the one body, I am supplying heat to this body. If I supply, so temperature is a dependent variable. Okay, it will vary with respect to some input. Input is heat supply. Okay, so if I supply some amount of heat, that initially it is at some 20 degree 28 degrees Celsius. Now if I supply the heat, the temperature of the body will increase. So that the study of interrelation between heat and temperature is thermodynamics. Okay, now the basic concept, first you have to understand what is system, what is surrounding and what is boundary. Okay, so that if you see this diagram, you can clearly understand what is system, what is surrounding and what is boundary. Suppose I am taking this blue color line, this blue color curved line you take as a system. Okay, the outer envelope of that system is boundary, and in which particular or you can say where I have kept the system. Okay, in particular room I have kept. So the anything outside the system is surrounding. Okay, outline of the system is boundary, anything outside from the system is surrounding. Now for example, you take my body. Okay, my body is system and my shirt is the boundary, and where I am standing now, inside one room I am standing. So that room is surrounding, my shirt is boundary and my body is the system. Now I think you have clearly understood about what is system, what is boundary and what is surroundings. Okay, this is some basic concept, you please remember. Okay, next, thermodynamic properties. In thermodynamic, properties are classified into two. One is intensive property, another one is the extensive property. So intensive property is defined as the independent of mass. These properties will not depend on mass. Suppose if you take this body, if I increase the mass or size of the system, the property will not change. Some of the properties are there, that properties are not depending on the mass or size of the system. That properties are intensive properties. Extensive properties always depend on the, what is that? Extensive properties always depend on the mass or size of the system. Okay, that will vary when you vary the mass or size of the system. So what are the examples for intensive and extensive? Intensive properties example, pressure, temperature and density. So that properties will not vary and that properties are not depend on the size or mass of the system. Extensive properties examples are mass, volume and entropy. So that properties will vary with respect to the mass or size of the system. If you increase the size of the system, mass will change, volume will change, entropy also will change. So such properties are extensive properties. To understand that better, I will give you one more explanation about this so that you will easily understand. In a simple container, what I have taken one gas. It has mass, volume, pressure, temperature, density. Okay, now what I am doing, I am just splitting the container into two halves. Now single container is split into two halves. When I split into two halves, the mass will become m by 2. Here some 50% of mass will be there, here some 50% of mass will be there. Then volume also will become 2. Here some 50% of volume and there some 50% of volume. But if you come to pressure, if you divide the particular system into n number of partitions, then anywhere if you check the pressure will be remains constant. The pressure will not vary with respect to space. So pressure is not a function of x, or if you take in x-axis, it's not a function of space. Okay, so that pressure will be constant. Similarly, temperature also not a function of space. Okay, so that if you check the temperature at any partitions of the system, if you divide the system into n number of partitions, at all the partitions pressure and temperature will be remains same only. Density also same only, density also will not vary. So that you can say if the properties are not changing with respect to the size of the system. Now you see the size I have increased. Okay, so that when I increase the size or mass of the system, some properties will change, some properties will not change. So that properties which are not changing are intensive properties, properties which are changing are called extensive properties. So the best example for extensive properties are mass, volume, okay, that are, and entropy also you can say extensive property. Okay, and the intensive properties are pressure, temperature and density. These are the intensive properties. Okay, next, system are divided into three. One is the open system, another one is the closed system, then last one is the isolated system. Okay, so what is open system? Open system means mass and energy transfer can take place. Okay, open system is a system where mass and energy transfer will take place. Okay, what is the example for open system? If I take a one steady flow, okay, so I am taking one container, two parts like inlet and outlet, both are in open. I am sending some water into that. Suppose I am taking one heat exchanger where I am sending some amount of water inside, so that it is going inside, there some heat exchange will take place and it will come outside. So how much amount of quantity that I am sending, same will not come, some amount of quantity will come less or increase, so that mass of the quantity what I have sent is also changing. There is some changes in the mass and there is some changes in the work and heat also. So that here three things we should remember. One is mass, another one is the heat, another one is the work. Okay, so three things are there to understand about the types of system. Okay, if the system is open system means then there will be the mass transfer, there will be the heat transfer, there will be the work transfer. Sometimes heat and work they will combinedly say as energy. So open system is a system where mass and energy transfer take place. And if you come to the closed system where there is, suppose you are closed, that is the system which don't have any opening. So if there is no opening, then how the mass of the system will vary, how much quantity that you are sending. Suppose you are filling the water in the tank, I am closing the tank. What will happen? How much quantity of water I am filled inside? When there is no opening in the tank, that much quantity only will be there. So that type of system is closed system. The best example for the closed system is engine cylinder. So in engine cylinder, it is a closed one. Okay, where I am sending the fuel. Okay, the quantity is not changing, but there is some heat transfer and work output. So that during that working stroke, that is power stroke, heat is produced. So the produced heat is converted into useful work. How much amount of heat is produced? Not 100% converted into work, but some amount of work is converted into work. So there is some interactions between work and heat. Work transfer done, heat transfer also done. So closed system is a system where there is no mass transfer, but there is a transfer of energy. So that type of system is closed system. Isolated system is just directly opposite to this closed and open system, where there is no mass transfer, there is no heat transfer, there is no work transfer, nothing will happen. So that mass transfer not possible, heat transfer not possible, and work transfer also will not be possible. So that it is an insulated system, adiabatic system. Okay, when the system is insulated, there will not be any change in the heat. Okay, there will not be any possible for the heat transfer. When there is no heat transfer, work also not possible. So that system is called isolated system. Okay, these are the types of system. Next, thermodynamic processes. In these 5 thermodynamic processes are there. First one is the constant volume process. Constant volume process is also called as isochoric process. Okay, so volume process means volume is constant. Sometimes they will mention the process name as isochoric. You don't get confused. Constant volume or isochoric, both are same. Next, constant pressure process, which is isobaric process. Okay, constant pressure process where pressure will be constant, right? Then constant temperature process where temperature will be constant. It is also called as isothermal process. Next one is isentropic or reversible adiabatic process where entropy will be constant. Okay. Next, polytropic process. These are the 5 processes in the thermodynamics. Okay. Next one, we will see the Wotton equation for all these 5 processes. Okay, so first you see the generalized work equation. So what is work? Work is equal to force into displacement. Okay, so force is F, x is the displacement in x axis, suppose I am considering. So but force, I can say that pressure by area, pressure is equal to force by area. Now I am going to integrate, so that dW is equal to, I can say the change in work, that is dW is equal to F into dx. If I integrate that, instead of F, if P is equal to F by A, I can write F is equal to P into A. So PA is constant that I am taking outside, not constant. So A into dx. A into dx means what? A is in the unit of meter square, dx is in the unit of meter. A is the area of the system, dx is the distance travelled by the system. So if you multiply that, you will get the volume, meter squared into meter cube. So that I can put instead of A dx as a change in volume. Okay, so that multiplication of area into distance is volume only. Okay, that is area and length. So dV. So So now I am going to integrate dW. If I integrate dW, it will become W. Then integration 1 to 2, P is constant, dV. So P dV, integration of P dV. So W is equal to integral of P dV is the generalized W formula for the thermodynamic processes. Now you come to the process. First one is the constant volume process. Constant volume or isochoric, both are same. In constant volume process, you please do remember, volume will not change. Suppose you take this PV diagram. In the PV diagram, process number 1 to 2, if you take, in the x-axis I have taken the volume. So I have drawn one vertical line. So what the vertical line is indicating, volume V1 is same when it is reaching the state 2 also. So volume is not changing, that's why volume V1 equal to V2. Suppose the process is starting at point number 1 here, it is reaching the state point number 2 here. So in this process also, volume is constant only, volume is not changing. That's why this process is called as the constant volume process. So I can derive the formula for constant volume process from the PV diagram also. So always you do please remember, area under the PV diagram is work transfer. But in this there is only point. When there is a point, then there is no area. So I can say in the constant volume process, work done formula, work is equal to 0, because it is not moving. When it is not moving, then there is no possibility for the work to be done. So that in constant volume process, always work done is equal to 0, right? So that I can derive it mathematically also. What is the general formula for W? Integral of P dV. Volume is not changing, so P into 0, so W is equal to 0. So this is the constant volume process, work done formula. Next one is the constant pressure process. So constant pressure process, what will happen? By the name itself we can easily understand, pressure is constant. So you see this horizontal line is indicating that pressure is constant. Pressure is not changing, but volume is increasing. Okay, so that this is, you can say that in the diesel cycle that we will see in the further videos, where the heat addition is taking place at constant pressure only, but volume will increase. So volume is increasing from point number 1 to point number 2, which is P1 is equal to P2. Volume increasing, but pressure is not increasing. So area under the PV diagram is what? Work. So if I take this will become a rectangular. So rectangular area is length into width. So length is what? V2 minus V1. Width is common, pressure is not changing, so that this is length, and volume is increasing, that is V2 minus V1. So this I can also prove, this pressure is constant, okay, and this volume is increasing, V2 to V1, okay. Now you see in mathematical equation for this, W is equal to common equation, P into dV. If I integrate dV, it will become V. Then it is increasing from 1 to 2. Then if I substitute upper limit minus lower limit, then the equation will become W is equal to P into V2 minus V1. So this is the generalized W equation for W formula for constant volume process. For constant volume process, W is equal to P into V2 minus V1. This is how this equation have come. Okay, so this formula you please do remember. In numerical problem, this type of question they will ask. They will give us the question, they will give the pressure value, and they will give two volumes value, and they will mention in the question, this is constant pressure process, find out the work done. So what is the formula for work done? W is equal to P into V2 minus V1 for constant pressure process. Okay. Next one, constant temperature process. Where in constant temperature process, the curve is hyperbolic. Okay, if I derive, it will become very large, so that I no need to derive. So, and also you do remember, internal energy of any system is always directly proportional to temperature, but in constant temperature process, I am saying that the temperature is not changing. Okay, then how the work is done? Okay, so that how the work is done when the temperature is not changing, so that I have already told you that every system has its own internal energy, even though there is no supply of heat. So that why I no need to supply any heat for this system, because if I supply the heat to the system, then if the process is constant temperature process or isothermal process, then I should not supply any heat. If I supply heat, the temperature will increase. So it's an adiabatic process kind of thing. Though it's not adiabatic, it's isothermal, I am not changing the temperature. Okay, so in that case, how the work is done? Because it has some internal energy. Now suppose you consider you are having high fever. Okay, in high fever time, if you want to take some water from long distance, So even though you are having some high fever, you are not able to sit and you are not able to walk, but if you want to take something, you can go, you can move little bit and take some amount of water from there and have. So that is internal energy of your body. Similar way, if there is no supply of heat also inside the engine piston cylinder, the piston will move little bit distance. So that is how the work is done in constant temperature process. Okay. So for constant temperature process, PV is equal to MRT is the ideal gas equation that we will see in the next videos how this equation came. Now from this equation I can say M and R will vary for different gases. So now I am not taking that, I am just taking this is constant. So PV is equal to T. So I know for constant pressure process, constant temperature process, temperature is constant. So PV is equal to C. So P is equal to C by V. So what is formula? P into dV. So instead of P I can put C by V. So C by V. So that here C is constant, I am taking outside, dV by V. If I integrate 1 by V, it will become ln V. So ln V of limit 1 to 2. So if I substitute the upper limit minus lower limit, it will become ln of V2 minus ln of V1. So anything in the subtraction you can write in the divide, that is mathematical concept. So the work done formula finally I am getting for constant temperature process is W is equal to PV ln of V2 by V1. This is the work done equation for constant temperature process. Okay. Next one, adiabatic or isentropic process. This is also if we take as a derivation wise to find out the efficiency or work done formula for this, then it will become a very big derivation. That part we no need to concentrate. You just remember only the formula for isentropic process. In isentropic process you do remember entropy is constant. Okay. So the formula, work done formula for isentropic process is P1 V1 minus P2 V2 by gamma minus 1. Polytropic process also same formula. Instead of gamma you just put N. So P1 V1 minus P2 V2 by N minus 1. So that isentropic work done formula is P1 V1 minus P2 V2 by gamma minus 1, and polytropic work done formula is P1 V1 minus P2 V2 by N minus 1. Okay. Next one. So that this is sometimes in question paper they are asking graphically. Okay. So PV power K is equal to C is the common term. Suppose if I put K is equal to 0, then I will get P is equal to C. Okay. So here I am marking PV diagram. If pressure is constant, then I will make one constant pressure line. Okay. Next. Okay. Then if K is equal to 1, okay. If K is equal to 1 means what will happen? PV to the power of 1 is equal to C. So PV is equal to C. So PV is equal to C means what process? It is constant temperature process. So PV is equal to C is just coming below the constant pressure line. So this is constant pressure process. This is constant temperature process. Suppose if I put K is equal to N, then it will become PV power N equal to C. PV power N is equal to C is the polytropic process. So PV power N is equal to C will come under this curve. So this curve is indicating the polytropic process. If I put K is equal to gamma, then the equation will become PV power gamma equal to C. So the PV power gamma is equal to C is below this PV power N is equal to C. So this line is indicating the isentropic process. And similarly, if I put K is equal to infinitive, then after some further simplification, I will get V is equal to constant. So this vertical straight line is indicating the V is equal to constant, that is constant volume process. Sometimes in examination, they will give the diagram like that and they will name as A, B, C, D, E, and they will give some answer options. What is process A? What is process B? What is process C? What is process D? And what is process E? They will ask. So that you do remember, A is, first one is the constant pressure, constant temperature, polytropic, isentropic, constant volume. Okay, this type of questions also they are asking. So you just note down. Next one. So what are the things that we have seen? I just made one table column because while solving numerical problem, this table column will help you. So you just listen this table column. Constant volume process. In constant volume process, actually there are three properties: pressure, temperature, volume in thermodynamics in all the processes. Suppose I am talking about constant volume, then the volume will not come into play. So I will play only with the pressure and temperature. So for constant volume process, this is the pressure and temperature relation. P1 by P2 is equal to T1 by T2, because in question paper they will mention this is a constant pressure process, this is the initial pressure of the gas, this is the initial temperature of the gas, and this is the exit temperature of the gas. Find out the exit pressure. So P1 is the initial pressure, P2 is the exit pressure. Similarly, T1 is the initial temperature, T2 is the final temperature. So that if you know the pressure temperature relation for every processes, you can find out the unknown properties. So that you do remember, and this is the chart that we have seen already. Graph you no need to worry, we have seen this already. Same one I have drawn. Then work done formula we derived for constant volume process, works equal to 0. Okay. Next, constant pressure process. Here pressure will not come into play. I will play only with the volume and temperature because this is constant pressure. So the property relation for constant pressure is V1 by V2 is equal to T1 by T2, and work done formula for constant pressure is P into V2 minus V1. Okay. Next, constant temperature or isothermal process, where P1 V1 is equal to P2 by V2 is the property relation. Next one, the work done formula for constant temperature is P1 V1 ln of V2 by V1. That is the work done equation or formula for constant temperature or isothermal process. Okay. Next one, isentropic. For isentropic, P1 V1 power gamma equal to P2 V2 power gamma. That is the property relation. Okay. Next one, W formula that we have already seen. The W formula for polytropic or isentropic. Suppose if it is isentropic, denominator term will be gamma minus 1. If it is polytropic, denominator term will be n minus 1. So that's all. Okay. Next, laws of thermodynamics. In thermodynamics there are 3 laws. So this is important, very basics in thermodynamics. Zeroth law, first law and second law. So we will see one by one. First we will see zeroth law. Zeroth law is the measure of temperature. For example, you see this, there are 3 bodies A, B and C. Okay. So that what is the definition? When 2 bodies or system are in thermal equilibrium with the third body, then there are thermal equilibrium with each other. So that I am taking 3 bodies, bodies A, body B, body C. Now this A body and B body both are in thermal equilibrium. Thermal equilibrium means the temperature of the 2 systems are equal. Okay. Now that 2 bodies are in thermal equilibrium. Now these 2 are in thermal equilibrium with another body also. See, so initially body B is in thermal equilibrium with body A, and also body B is in thermal equilibrium with C also. Now these 3 bodies are in thermal equilibrium. When any 2 bodies are in thermal equilibrium with each other, then third body also will be in thermal equilibrium. Okay. So that this is how this is the zeroth law of thermodynamics. So first law, second law we will see in the next session. Okay.